AI is going to bring a new renaissance for humanity, a new form of enlightenment, if you want, because AI is going to amplify everybody's intelligence. It's like every one of us will have a staff of people who are smarter than us and know most things about most topics. So it's going to empower every one of us.
Yann, I am so excited for this. I heard so many great things from our mutual friends, obviously David Marcus and then Mathieu at Photo Room. So thank you so much for joining me today.
And it's a pleasure.
Now, I would love to start. I heard some of the early stories, but I want to start with one from David Marcus. How did you first enter the world of AI and make that first foray?
I was still an undergraduate engineering student in France, and I stumbled on a philosophy book, which was a debate between Jean Piaget, the cognitive psychologist, and Noam Chomsky, the famous linguist. And they were arguing about nature versus nurture for language, whether language is acquired or innate. So Chomsky was on the side of innate, and Piaget on the side of acquired with, some innate structure. And on the side of Piaget was a guy called Seymour Papert, who was a professor at MIT. In his argument, he talked about something called the perceptron, which was an early machine learning system. And I read this and discovered that people had been working on machines that could learn, and I was fascinated, and I started digging the literature. Soon discovered that much of that literature was in the 1950s and 60s and basically stopped in the late 60s because of a book that killed it. And Seymour Papert was a co-author of that book. So strangely enough, and here he was 10 years later actually praising the perceptron as kind of an amazing concept. So I was hooked. I started getting interested in what was not yet called machine learning, but eventually became neural nets and now deep learning.
Can I ask you, David asked this as well, how long did it take to get, in terms of like the major breakthroughs, how long did it take you to get to the major breakthroughs that you're at the origin of when you look back over that time to get to those major breakthroughs?
Well, so there's a few breakthroughs. So the first one was when I was still an undergrad, basically finishing my engineering studies, figured out that the way forward to kind of lift the limitations of the old systems that were abandoned in the 60s was to find learning algorithms that could train multi-layer neural nets, essentially. And people had all but abandoned this type of research, except for a handful of people in Japan. And one guy I heard about called Jeff Hinton, who had published a paper in 1983. So this was just the year I graduated, on something called a Boltzmann machine, which was clearly a method to go beyond those limitations. And so I had, on my side, kind of developed a method for training multilayer nets, which was very close to what we now call backpropagation, but not exactly the same. It was closer to what we call target prop, actually, nowadays. And then, published a few papers in French and eventually met Jeff at a meeting in France in 1985. And we realized we'd been working on the same thing and we're thinking alike. But I was, in the middle of my PhD, and he was a associate professor at Carnegie Mellon. So we started, a discussion, and then, visited him at Carnegie Mellon for a summer school he organized. And then when I finished my PhD, I did a postdoc with him, and then joined Bell Labs. And while I was in Toronto, I developed what was called convolutional nets now, convolutional networks, which, is a major method for image and speech processing nowadays. And so that's what I'm best known for, but it started much earlier.
I have to ask, Joshua described kind of the hype cycles within AI and neural nets like deserts when you're not in them. And he asked the question, how did Yann not get discouraged when for a solid decade we were in a desert where no one really cared about neural nets? How did you keep the enthusiasm, bluntly, when, as Joshua said, no one really cared?
Both Joshua, Jeff, and I had in the back of our minds that those methods would eventually come to the fore, and that, we would have to kind of snap people out of their preconceived ideas about neural nets. So yes, there was, so Joshua and I were actually working together at AT&T Bell Labs in the early 90s. And then the interest of the community for those methods started waning around 1995 or so. And there was indeed about 10 years when not only nobody was interested in neural nets, but people were even making fun of it, talking about it in sort of disparaging terms. Now, there is something, though. In 1996, I kind of changed job. I stayed in the same company. I was still working at AT&T in the research labs, but I became a department head, and this was the early days of the internet. And my group and I started working on something completely different that had nothing to do, or not much to do, at least with machine learning. It was image compression. I had this idea that with the internet coming up, we should have a way of scanning existing paper documents and then, put them on the internet so that everybody could have access to them. And so I worked on this for 5 or 6 years together with Leon Botou, who had been a long-term collaborator. Joshua was also involved peripherally, and a bunch of other people, Patrick Hafner, etc. And that project ended when all of us basically left AT&T. That's when I restarted working on deep learning. And Jeff also kind of came back to Canada. He had been in the UK for a while. And Joshua, Jeff, and I decided in the early 2000s to basically start a conspiracy to, revive the interests of the community in neural nets by making them work, discovering new algorithms. And, it took almost 10 years, but it succeeded beyond our wildest dreams, basically.
So I'm going to ask you a range of varying questions in terms of depth, breadth, and kind of obvious and non-obvious. So forgive me if some are obvious. I just want to ask, when I hear the historical context there from you over many decades, how do you feel today when we look at what's happening today? Are we at a new inflection point in development, or is this merely the continuation of what we've seen for many decades?
It's a combination of the two. So on the one hand, a lot of what we see today, when you are kind of down in the trenches of research, looks a logical extension. I was not as enthralled by the sort of recent progress as the public was, because, I've seen this progress happening over the last several years. Now, there are things that have been very surprising. The fact that self-supervised learning methods applied to transformer architectures work amazingly well, and they work, way beyond what we could have expected. The fact that we can do basically train systems to understand language, translate language in multiple languages, and then, continue text if you train them to do this, or answer questions if you train them to do this, works amazingly well to an extent that, people didn't quite expect that, was going to happen by just making them bigger and training them on more data. So that certainly has been surprising for everybody. But that revolution occurred 2 years ago, right? So whereas the wider public, has learned about it through ChatGPT that, was made available, for us, it's been more continuous. And you see this in, a lot of marking events in technological progress or in AI in particular are marked by kind of splashy events that the public pays attention to. But to many of us, it looks like more like a continuous thing. And generally what those progress require is a bunch of people to take the techniques that already exist, push them a little further, do a bit of engineering, and then make a demo that demonstrates that it works. So that was the case for, Deep Blue, the chess player that IBM built in the mid-90s that beat, Garry Kasparov. Same thing with the DARPA Grand Challenge that Sebastian Thrun team at Stanford won, a car that could drive itself in the desert, right, for 100 miles. And then, AlphaGo and the IBM Jeopardy, there's a number of those things, right? And, ChatGPT just being the latest one. And it looks like kind of jumps when you look at it from far away, but when you're in the field, it's more like a continuous evolution.
Can I ask, has there been any other surprising, on the positive side, developmental things you've seen over the last year or so? You said about self-supervised learning and the efficiencies there. Is there anything else where you're like, I didn't expect it to go as well as it has done in the last year?
Yeah, so I already mentioned it. The fact that merely training a language model to predict the last word in a sequence of words, if you do it properly, you get a system that has capabilities that are somewhat unexpected, and they emerge as you make those systems bigger and you train them on larger amounts of data. That's clearly been a surprise for everyone. Now the thing is, as researchers and scientists, we're always looking for the next thing. So what I'm interested in at the moment is, what goes beyond that. A lot of people are going to work on applications of autoregressive large language models, which is great. There's going to be a lot of products and new ways for people to do things, and it's going to be wonderful. But I've already been thinking about the next stage for the last 4 5 years even, actually more, which is like what's missing from those systems.
What are your thoughts on what's missing from those systems? In that logical next step, where does that lead you in your thinking?
So those systems do not have anywhere close to human level intelligence. Okay, despite what you might think, we are kind of fooled into thinking it because those systems are very fluent with language, but their ability to think, to understand how the world works, to plan, are very, very limited, and their understanding of the world is very superficial. And the reason for it is that they are strictly trained on language, and language only contains a small proportion of all human knowledge. Most of human knowledge is not linguistic at all, and all of animal knowledge is non-linguistic. And we take it for granted. This is the Moravec paradox, right? All the capabilities and abilities that we take for granted, like, planning a motion or something, or very simple things that everyone can do. A 10-year-old can, clear up the dinner table and fill up the dishwasher. Any 17-year-old can learn to drive. We still don't have self-driving cars. We don't have domestic robots.
If they're non-linguistic, like the majority, I'm sorry for the base questions, but then what are they? And is that we don't have able to be ingested by AI models and engines over time?
Well, so first of all, there is no question that eventually AI systems will understand the world in similar ways that humans do, perhaps better ways. But they will not be autoregressive large language models of the type that we're now talking about. They will be different for a number of different reasons. But to answer your question more directly, anything that has to do with sort of an intuition of the real world requires an experience of the real world or a simulated version of it, which those large language models don't have. They purely train from text. So there's a number of questions that about the physical world that they'll be able to answer because there's a template for it or something very similar in the data that they've been trained on. Same for planning. You can ask them to, plan a trip or something, and they'll adapt a template that they've been trained on. But they don't really have sort of a mental model of how the world works that allows them to plan complex action sequences or use tools or things like that.
Can I ask, is that why you said that AI researchers facepalm when they hear prophecies of doom?
No, that's a different question. Those are kind of orthogonal concepts. So, there is some weak connection. There is a flaw in current autoregressive LLMs, which is that you can only control their answer in two ways. The first way is you modify the statistics of the training data that you train them on, possibly using human feedback for specific answers. And the second one is you change the prompt. And the combination of the prompt that, the question you ask them, the form in which you ask the question, and the statistics of the training data entirely determines the answer that the system will produce.
Sure.
So there is no persistent memory, first of all. But second of all, you cannot control the system. You cannot impose constraints on it, like be factual, be understandable by a 13-year-old. You can try to put this in a prompt, but then, you rely on whether the statistics of the training data is appropriate for taking that into account. But there's no direct way to constrain the answer of those systems to satisfy certain objectives. And that makes them very difficult to control and steer. And so that creates some fears because people are kind of extrapolating, if we let those systems do whatever, we connect them to the internet and they can do whatever they want, they're going to do crazy things and stupid things and perhaps dangerous things. And we're not going to be able to control them, and they're going to escape our control, and they're going to become intelligent just because they're bigger, right? And that's nonsense. First of all, because this is not the type of system that we are going to give agency to. The systems that will eventually be given agency, that are going to be able to plan sequences of actions, are systems that are going to have objectives that they're going to have to satisfy. And because of those objectives, they're going to be controllable. So they're going to be much more controllable than the current systems. Okay, so my prediction is that within a few years, nobody in their right mind would use autoregressive LLMs. They'll go away in favor of something more sophisticated and controllable that can plan its answer as opposed to just produce one word after the other reactively. Okay, that's the first fallacy. The second fallacy is that there is this idea somehow that the desire to and the ability to dominate is linked with intelligence. right? So this is a statement that a lot of people are making, including, my friend Jeff Hinton recently, that somehow as soon as a machine becomes intelligent, it becomes uncontrollable because, it being smarter than us, it can influence us in ways that we can't even imagine. Now, I think this is a gigantic fallacy because even within the human species, it is not the smartest among us that want to dominate the others. Okay? To dominate other entities, you don't necessarily need to be smarter than them, but you need to want to dominate them. This is not something that every intelligent entity is going to do spontaneously. We do it as humans because the desire to influence others was built into us by evolution because we are a social species. Okay, same as baboons and chimpanzees and wolves and dogs and etc. It's not the case for orangutans. Orangutans don't have the desire to dominate anybody because they are non-social animals. They are solitary animals. They are territorial, in fact. So we need to separate those two concepts: the will, the desire, and the ability to dominate on one hand, and intelligence on the other hand. The fact that we're going to have super intelligent machines at our disposal means that every one of us is going to be like a business leader, a politician, or an academic with a staff of people working for them that are more intelligent than themselves. I mean, it's great. It's not like if you feel threatened by, being the boss of other people who work with you but are smarter than you, you're not being a good leader.
Can I ask then, how do we instill values within models where they don't have a desire to dominate?
Right. So these objectives I was telling you about. So let me describe the sort of architecture of future AI systems as I see it. We're going to have AI systems that basically are going to plan their actions, and actions can include sequences of words that you tell someone, but they're going to plan those sequence of actions or words so as to optimize a series of objectives that we set them. Okay, So one objective is, does this answer the question I just asked? Okay, another objective might be, well, you're talking to a 13-year-old, make that answer understandable by a 13-year-old. Another objective might be, I asked you to answer a question about the world, so be factual. Or it's a question about, yesterday's political event. Can you kind of be compatible with everything you've read in the press this morning? Things like that, right? So you'll have those systems that have, a series of objectives, and their output, their answer, by construction, is going to have to satisfy those objectives. And some of those objectives will be hardwired to make those systems safe. Like if it's a domestic robot that can, cook dinner and can wield, kitchen knife in its arm, there's going to be a term in there that says, like, stop moving your arm when there's people around because, you might hurt them. So that's going to be an objective that the system cannot violate because by construction, it's going to have to satisfy them. So that's the way to build safe AI system. You make them produce answers that by construction have to satisfy objectives, and you design those objectives so that their actions are safe. Now, how precisely to do this is not a completely solved question, but you try it, you deploy it at a small scale, you see what the effect is, and you correct it when it doesn't work, and you fix it progressively. And it's not like if you get it wrong, it's going to destroy humanity.
Depends on that cooking robot. You never know. How do you determine who's able to set the objectives? Because there could be right or wrong depending on who sets them.
That's true. So that's going to have to be there's going to have to be a process by which we allow people to do this, like some vetting process. The same way that there's a vetting process for people to take care of your health or cut your hair, fix your plumbing or your car, right? So there's some some vetting process, certainly some testing and market deployment procedure with regulating agencies for things that have that are potentially dangerous. Probably not for all applications, but for many applications, certainly in healthcare, transportation, and things like that. And then perhaps also it could be that let's take the example of intelligent assistants. So let's imagine a future where everyone can talk to their intelligent assistant. That system will have pretty close to human level intelligence, probably more accumulated knowledge than most humans. they could translate in any language and give you a quick summary of yesterday's newspaper and things like that, right? Explain mathematical concepts to you, things like that. So people are probably going to use this almost exclusively in the future for their interaction with the digital world. You're not going to go to Google or Wikipedia. You're just going to talk to your assistant. And the only way to do this properly is for the base infrastructure for those assistants. I mean, they will be so pervasive, so much will ride on those systems that I don't think anyone will accept that those assistants be behind a event horizon in a private company. They will insist that the infrastructure is open. They will insist also that the vetting process by which those systems are trained be something maybe like Wikipedia, right? We tend to trust Wikipedia, sometimes with a grain of salt, but we tend to trust Wikipedia because there is a vetting process so that whenever an article is modified, some editor kind of check on it and then the changes are accepted or not, things like that. So you can imagine that the sort of common repository of all human knowledge that will be our assistants will be constructed through some sort of crowdsourcing process, perhaps similar to Wikipedia, where you're going to have a bunch of people training those systems and fine-tuning them so that, whatever the answer they produced are correct.
It's so funny you say about that, kind of the benefits there of the open approach over the closed approach, because that's where I've been kind of stuck, which is like, where does value accrue? Is it to the closed model or the open model? And then we had the leaked internal memo today from the Google employee who said, we're not ahead, OpenAI are not ahead, there's this third being which is actually far more significant and we haven't taken notice of, and summarized.
Right. And that was triggered by LLaMA, which is the model that was put together by my colleagues at FAIR, which was the code was open sourced. The model, sadly, was distributed only for research and non-commercial purpose. And the reason for that is basically complicated legal issues of what's the status of the data that those systems have been trained on and things like that. So it's more kind of, it's not a lack of desire from Meta to open source. It's more kind of complex legal issues that go beyond my.
I'm super naive, Yann. Why does open win against a more controlled, tight-knit, well-funded OpenAI or other large corporate with a big balance sheet and a very rigorous but streamlined team?
It's very simple. It's because no outfit, as powerful as they may be, has a monopoly on good ideas. So if you do it in the open, you basically recruit the entire world's intelligence to contribute to things and having ideas that you may not have thought about, which an outfit with 400 people has no chance thinking about, or even a large company with 50,000 employees may not want to devote any resources to because they may not think it's useful in the long term, or they have more urgent thing to take care of. So you give it away, and then you have tons and tons of people, some of whom are undergraduate students or people in their parents' basement, so coming up with amazing ideas that you would never have thought about, or willing to spend the time to crunch down the 7 billion weight LLaMA so that it runs on a Mac, on a laptop. It's pretty amazing. So I think that's why open source projects succeed, particularly when they concern basic infrastructure. So if you think about it, the early days of the internet, there was a battle between Microsoft and Sun Microsystems to provide the basic infrastructure for the internet. The operating system, the web server, things like that, right? So on Sun Microsystems, there was Solaris and whatever web server and Java, and then on the Microsoft side, that was Windows with IIT or whatever, an ASP, which was their kind of server and client side protocol. Both of them lost. In fact, Sun Microsystems pretty much went bankrupt and was sold for parts to Oracle. One was Linux and Apache, which is completely open source. And you might ask why. The entire internet and the entire tech industry runs on Linux, right? And your phone probably runs on Linux too if you have Android. So that's 3/4 of the phones in the world. So the reason for this is that it's just a much better way of gathering competence and talent around a common project, even if it's not motivated necessarily by profit.
Yeah, and I agree, and I love this. You work with Meta. My question and David Marcus's question was, how does Meta win then?
So it's been the case that Meta in the past has open sourced pretty much everything that it's ever produced in terms of basic infrastructure, right? So you have, React for, the framework for web and mobile apps. You have PyTorch. PyTorch is not even owned by Meta anymore. The ownership was transferred to the Linux Foundation because it's so essential to the, AI R&D infrastructure nowadays. ChatGPT was developed on PyTorch. Okay. All OpenAI runs on PyTorch. The entire world, in fact, runs on PyTorch except Google because they have their own thing, right? But it goes beyond that, right? Meta open sources its hardware server backplane design so that hardware manufacturers can build to its specifications. And pretty much everything, aside from sort of legal issues that are sometimes due to kind of recent laws or court decisions, pretty much everything has been open sourced. It is not because other people can use your technology that you can't exploit it to the same extent, right? Who can use smart NLP systems for, translation or content moderation on Facebook other than Facebook? It doesn't matter if other people have access to the same technology.
I mean, so I totally agree with you. And this kind of led to my next question, which you actually tweeted about, which comes to the size of data moats and size of data availability. Is it simply a case that the largest model wins? And how do you think about value in small models as well?
Yeah, so it's not the case. And this is really what LLaMA has demonstrated and really kind of shown people. So the people behind LLaMA, Edouard Grave and Guillaume Lample, and then their collaborators, mostly at Fair Paris, actually, many of them are in Paris. They've demonstrated that you don't need those models to be very large to work really well. I think it caused a bit of a epiphany for a lot of people, realizing, you don't need, okay, maybe you need 1,000 GPUs, running for a couple of weeks to train it, the base system. In fact, that number is going down too because people are kind of figuring out how to do this more efficiently. But once it's pre-trained, you can use it for all kinds of stuff, and you can fine-tune it really easily. And then at the end, you can run it on your laptop, right? That's kind of amazing. Or maybe on a desktop machine with a GPU in it or a couple of GPUs. So I think, it sort of opened the minds of people to the fact that there is enormous opportunities that really weren't thought to be possible before. And I think it's going to make even more progress because if we go towards the design of AI systems, perhaps along the lines of what I described with objectives and planning, I think those systems could actually be even smaller to some extent.
How would they be even smaller? Sorry, unpack that for me.
Well, because the current models, for them to work, you have to train them on gigantic amounts of data. Yeah. Way more data than any humans has ever been trained on, right? So the amount of data LLaMA is trained on, for example, is something like 1.4 trillion tokens, which is it's like a quarter of the internet or something. It's something absolutely enormous. It would take someone reading 8 hours a day at normal speed about 22,000 years to read through that. Okay, so obviously those systems can accumulate a lot of knowledge from text, but they don't do it the same way humans do it because we don't need that much time to be that smart and to learn that much. So obviously we are much more efficient. Our brains are much more efficient than those models at learning things. Like, how is it that a teenager can learn to drive a car in about 20 hours of practice? We still don't have level 5 self-driving cars. So obviously we're missing something really big. And what we're missing, I think, is abilities for AI systems to learn how the world works by observation, mostly. And then this ability to plan so as to satisfy objectives. And then beyond that, the ability to set sub-objectives in the satisfaction of a bigger one. Okay, that's called hierarchical planning. And we do this, humans do this. Some animals do this to some extent. Every animal is, mammal and bird is capable of some level of planning. Autoregressive LLMs basically don't do planning, or a very simple form of it.
Yeah, and you mentioned the efficiency that can come from actually smaller models than expected, and how actually size of models isn't everything. The other thing, we spoke about open and closed. The other thing that been thinking, and everyone's been thinking about, and I've interviewed many kind of leading AI experts, and they say the value will accrue to the incumbents. Startups, they don't have the data, they don't have the models, it'll accrue to the incumbents. Is that right? Will the value accrue to the incumbents? Or do you believe that given what you just said about size not being everything in terms of models, it could be startups as well?
So it depends on which scenario you believe in. So the scenario I think will happen, and I'm certainly rooting for, is the scenario I described earlier, where you have some sort of open platform for base LLMs. So base LLMs basically would be seen as a basic infrastructure, like, TCP/IP, Linux, Apache, essentially, completely open. And then there would be an ecosystem of companies building stuff on top of it, which for vertical applications, for specific things, right? To specialize those systems for particular applications, to offer support, to make it, customized for enterprise applications, for personal things. I mean, there'll be like a whole economy around this, which will create jobs, by the way, not make them disappear. So this is the scenario that I believe will happen. And the reason I think it will happen is because there is essentially a need to use essentially millions of contributions for making those systems factual and correct and etc. So Wikipedia style. So I think the proprietary approaches will actually fall behind. So that's one point, okay? The second point is you can ask yourself the question, how is it that the companies that were best positioned to produce something that ChatGPT, namely Google and Meta, didn't? Why is it OpenAI? Okay, a small outfit with, 400 people. I mean, more now, but actually a small outfit. And the answer is, it's not because Google or Meta did not have the competence or the technology. It's just that they didn't have the pressure to produce new products, completely new products, that had a lot of risk attached to them. And the risks were, and we know what the risks are, because a few weeks before ChatGPT, my colleagues at FAIR produced a large language model called Galactica, which was an experimental system, and they put out a demo, and the demo was to demonstrate that. So Galactica was a large language model trained on the entirety of the scientific literature. And it was basically designed to help scientists write papers. So you would start writing a paragraph or something like that, or describe the topic of a paragraph, and then Galactica would basically complete the paragraph, and it wouldn't be factually correct. You would have to kind of fix it, but it was like, you would ask it to like build a table result, and it would just, put the LaTeX commands to kind of build the thing and populate it with the known results from the literature about the topic that you're working on. Or you would type a chemical formula for something, and it would, turn it into an actual name for it, or things of that type, right? Very useful for scientists. As soon as the demo was put out, it was murdered by the social network Twitter sphere.
Why?
People said, oh, this is going to destroy scientific publication, because now, any random person can write a authoritatively sounding scientific paper that is, nonsense. And there was so much vitriol thrown at the system that the people at Meta who built it couldn't take it. They took down the demo because they said we can't sleep at night. So here is an example of a very useful system, a system that could have been extremely useful, particularly for writers of scientific papers who are non-native English speakers, that basically was destroyed by AI doomers. People who just did not think about the risk-benefit analysis. The risk of flooding the literature with nonsense is ridiculous. I mean, because, the scientific publications are vetted and things like that. So there was not a significant danger. And then ChatGPT came 2 weeks later and was welcomed as the second coming of the Messiah, right? So what does that tell you? And then, a few months later, Google came out with Bard, and in the demo, Bard made a tiny, minor factual mistake about some astronomical fact, and Google's stock went down by 8%. Now, what that tells you is that when something is produced by a large company that has a reputation, particularly a reputation to defend, they can put out things that spew nonsense, but it's okay for a small company. So that's the landscape of what happens now, which is why I think there's a bit of a paradox, which is that the companies that have the best technology basically can't have difficulties putting it out because of those legal issues and sort of public image.
Do you not also think there's just core business model challenge there, which is it's the classic innovator's dilemma? Like, why didn't Google do this? Because it would have killed that absolute cash cow of Google Ads. The cost to service a query versus the costs of this is so significantly different. You'd be killing your core cash cow with this, with unknown upside, versus retaining what is a great business.
You don't have a choice. I mean, there's no question that, within some time, it could take a while, but there is no question that people will interact mostly with the digital world using AI assistants. And, they may run into your augmented reality glasses, okay? So, or something of that type. Like, like in the Spike Jonze movie, Her, that's not a bad depiction of what, the way things could develop. And so if you take the assumption, you make the assumption this is going to happen, you have to build it as quickly as you can. And it might cannibalize your newsfeed algorithm or whatever, or in the case of Google, your search engine. But you have to do it. It's like, Meta has been known to make those choices in the past, like the move to mobile, for example, and the move to short form video, for example, which obviously TikTok has been very successful at. Meta has entered that business in kind of a big way, despite the fact that the amount of revenue it derives from it is lower than a traditional newsfeed, because it's hard to put ads in videos, basically.
You mentioned the job creation element there. I do just want to touch on the job side, because it's the classic AI doomer that we're all going to be unemployed and we're going to have universal basic income in an optimistic world. You said about job creation there. We don't hear about job creation through AI. How do you see what jobs will be created through this new ecosystem and what that world of employment could look like?
So 100 years ago, or maybe 120 years ago, most people in most of the world worked in the fields, in food production. There's pretty much a majority of the population. Today, in developed countries, it's between 1% and 2%. And that has caused, a migration of people into the cities and, the development of service business. Same thing 20 years ago, or, 20, 30 years ago, there was a big movement towards automation of manufacturing. And a lot of manufacturing jobs disappeared in developed countries, but they were replaced by other things. So 20 years ago, like, who would have thought that you could make a living with a podcast?
I didn't think I could 5 years ago, Yann. I'm as surprised as everyone else.
Right. So, a lot of jobs appear, like, 30 years ago, there was no such thing as web designer. And now it's, half the engineers in the world basically do this, right? So, the number of economists that I have talked to, which is pretty large, about where I asked that question, who tell me, well, we're going to run out of jobs because, we're all going to be replaced by think, is exactly zero. Like, no economist believes this. No economist believes we're going to run out of jobs, because no economist believes that we're going to run out of problems to solve or requirement for human creativity and human communication and stuff like that. So, this is going to create as many jobs as it makes disappear. Now, the question is, though, and those jobs, by the way, are going to be more productive. So overall, technology makes people more productive. In other words, for the same amount of hours worked, you produce more wealth, okay? But every technological revolution, unless it's accompanied by sort of, political changes and social changes, generally profit a small number of people, at least temporarily, right? That happened in the Industrial Revolution in the late 19th century, where, a few people became extremely rich and a lot of people were exploited. And then, society changed and there were like social programs and income tax and high tax for richer people and stuff like that, which, the US has backpedaled on this, but not Europe. Or the UK to some extent too, but not the rest of Europe. So there is a question of, how you distribute the wealth, if you want, okay? How do you organize society so everyone profits from it? But that's a political question. It's not a technology question. And it's not new. It's not caused by AI. It's just caused by technological evolution, right? It's not a recent phenomenon.
this is so unfair of me to ask, but what do those jobs look like? Like, what are they? Are they they're creative oriented, but what does that actually mean? Like, sorry, I know it's a really hard question, but I'm just trying to understand how we actually spend our time, and my children, which I don't have, by the way, Yann. But what do they do? Like, sculpt or paint? I don't know.
I don't know. That's a good question. But it's not because I don't know that it won't happen. Because, I mean, look at like how many people exercise their creative juices today, right? With all the tools that are available that, weren't available 10, 20 or 30 years ago. Like 3D artists or something like this, game designers, all kinds of things. I think creative jobs are the ones. So there are two types of jobs that have a bright future. Creative jobs, whether they are scientific, technical, educational, or artistic, anything that has to do with communication, right? And communication of human emotions, which is, intrinsically human, if you want. So that's one category. And then the other one is personal services, so where you need actual people to interact with you.
I totally agree and get you, and I love that. We shall see. Can I ask, the only thing that I worry about is like the speed of transition. Like when you look at past industrial revolution, when you look at even the introduction of PCs into kind of working environments, these were multi-decade introductions. Bluntly, what AI feels like in some industries today, we use it at the media company, and it's cutting our employment. Like the speed of transition is much, much more compressed in this timeline, which will lead to short-term significant high unemployment. Do you concede that, or do you not concede that?
So this is something I used to be very worried about, that the speed of progress of technology was going to leave a certain number of people behind who, cannot be basically retrained fast enough, or maybe they're too old to retrain themselves for the new world. I was worried about this. And then I talked to a bunch of economists, and they say, oh, not really, because the speed at which a technology disseminates in the economy is actually limited by how fast people can learn to use it. So a good person to talk to about this is Eric Brynjolfsson at Stanford. And what he says is that when a new technology is introduced, let's say the PC, right, with graphical user interface, the mouse, etc., right, in the mid-90s, how long did it take to have a measurable effect on productivity? Which is the amount of wealth produced per hour worked.
Yeah.
And he says, typically it's 15, 20 years. And the reason is that that's what it takes for people to learn to use that new technology, basically.
But you buy that here? Like, people are pretty good at prompts. Social media content managers are using prompts very efficiently to produce content plans, to create content ideas in under half an hour after watching a couple of TikToks.
Yeah. But, what is going to be the effect of this on... first of all, on measurable productivity. Second of all, on the job market. Is it going to make people lose their job right away? And no, it's going to take a while. It's going to take 10, 15 years, possibly more. It depends when you start counting, right? Because the AI revolution maybe started 10 years ago. So if you start counting then it might only take, another 10 years. But, I don't think you want to underestimate the degree of conservativeness of the business world, right? Things tend to change not that quickly.
Can I ask?
If it's that easy to learn, people will learn it and then invent new professions out of it, or become more productive themselves.
Why do you think we love the doom, Yann? I love your approach and mindset, and I agree with it. But why do you think we are kind of magneticized to we're all going to be unemployed in the doom?
Well, because I think for a number of reasons. So I'm not a social psychologist or a sociologist, but clearly, I think we're hardwired to pay attention to things that occur or may occur that could be dangerous to us, because it means that there's something about the world that we don't completely understand, and we do have to pay attention to it and be careful about it. So, for example, take a young child, 5-month-old, and show a scenario to the small child of a little car that is sitting on the platform, and then you push the car off the platform, and instead of falling, the car appears to float in the air. The 5-month-old will barely pay attention to it. But if you show this to a 10-month-old, the 10-month-old will look at it with huge eyes and stare at it for a long time, wondering what's going on. Because in the meantime, babies around the age of, between 6 and 9 months learn about gravity. They learn that objects that are not supported are supposed to fall. And so their mental model is that an object that is not supported should fall. And they see this object that appears to float in the air. And they say, like, this can be, like, there's something I don't understand about the world. I need to look at this and investigate. Okay, so we're hardwired for this because that's the way we learn our eternal mental model of the world that allows us to predict what's going to happen, allows us to plan. That's what makes us smart. That's the basis of intelligence, the ability to predict. And so we naturally pay attention to stuff that is surprising or dangerous or both, which is why, you see a outrageous piece of news, a clickbait at the bottom of some, website. And like, you have to convince yourself not to click on it.
Can I ask you a couple of direct questions? I'm just too interested, and we can take them out if needed. What did you say to Jeff when you heard that he was obviously making the moves that he did? I'm sure you had a conversation with him. What did you say to him?
We haven't spoken yet, actually. We're going to speak to kind of get, each other's opinion on it. I don't think he knows my opinion on this because I don't think he follows, what I post on Twitter or whatever, even though he is on Twitter himself. But so I think we have, a discussion to have. I've had this discussion before with Yoshua Bengio, but not with Jeff. And to me, the fact that he left Google is not particularly a surprise. The fact that he leaves Google to be able to speak his mind, I think is not surprising. So I have a very different deal at Meta, which is that I say whatever I want. Okay, I'm not under the tight control of the communications department or anything. I just say what I think. All right.
How did you get that deal, Yann? Like, no one has. No, seriously. I many of my friends are at Meta in very high positions, as we're mutual friends. They don't have that deal.
So there is, I mean, a particularly sweet spot because I have quite a bit of a following people who trust me or believe me or want to hear what I have to say, even if they don't trust me at all. And at the same time, I'm not an officer, so it's not like there are things I can't say because of legal issues of financial blah blah blah, right? I'm a vice president, but I'm just below the level where you have to be really, really careful and sort of control your message. And I think there is a cost-benefit trade-off here of, AI is such a complicated, fast-evolving issue that you need someone to be able to, speak freely. And okay. I think Jeff didn't feel like he had that option at Google, maybe, for various reasons. So I understand why he might have wanted to leave, but I don't agree with him at all with the whole sort of probability of human extinction or whatever.
Have you ever felt your role at Meta has impeded your ability to be impartial?
I don't believe so. No.
But
I mean, there are certain things that I would post on social media that are kind of propping up the work of my colleagues. And
sure.
I'm obviously biased about this because, I know about the work and they are friends and
sure.
or colleagues. And, I think it's interesting probably because, I've followed the projects. And
I totally get it.
Yeah. For this kind of stuff, I might be biased. Take this with a grain of salt. You don't have to believe me, things like that. But it's given me a vision also of, how things are built, what the problems are. So, for example, there's a narrative, a very, very common narrative that AI is the culprit for a lot of the bad side effects of social networks in the past. And in fact, it's completely backwards. AI is the solution to those problems. So, let me tell you, go back, backpedal 12 years ago or something, even before I joined Meta, where Meta, started experimenting with the newsfeed. And the newsfeed was, an algorithm that would pick which piece of news to show to everyone. And, originally it was decided by, how friends are you with the person making the post and things like that, right? How many interactions you have with that person. Eventually, a bit of machine learning was put into it shortly before I joined Meta. It was very, very simple. It was something like logistic regression, something like the simplest method you can imagine, with a lot of engineering behind it and a lot of, hacks by hand and special cases. But basically, it was something like logistic regression. some big vector that describes, what you click on, like how many times how much time you spent on a particular piece of content and blah, blah, blah. And then it would decide, like, give a rating to everything. So that was deployed, and people ended up, spending more time on Facebook. But then also it created problems that were quickly identified, like information bubbles in the context of political discourse. And the fact that what I was talking about earlier, that people tend to click on things that is more outrageous, right? So it caused the appearance of clickbait companies that basically were just like farms of teenagers in Montenegro or someplace making false news to get people to click on them and get money from the ads that they show them. So then this was realized. There were like big groups at Facebook at the time kind of studying what the effect of those things are, and this was corrected. So that's the way you make the system work, right? You try that on a small scale, you see what the effect is. If there is bad side effect, you correct it, and then you sort of compare, two systems. And then sometimes something unexpected occurs, and you have to backpedal and completely change the way you do things. So that's what happened in 2017 after the American presidential election in 2016. The main newsfeed algorithm was completely changed, so that there was no clickbaits anymore. There was no news outlets that could push their content that was propaganda, basically. Much more effort to take down false accounts and attempts to corrupt the democratic system and stuff like that, right? So you correct it. And then what the progress of AI over the last few years basically allowed systems to be deployed to do things like take down hate speech relatively reliably in hundreds of different languages, which was basically impossible to do before.
You mentioned correct it. I promise, last question, then we'll do a quick fire. You mentioned correct it. Elon Musk said with Tucker Carlson, the trouble with AI is you can't release and then correct. Unlike all prior technological developments, once released, it is too powerful to be able to bring back into the box. It cannot be amended in that way. Is that not true?
That's not true. That's completely false. It makes an assumption which Elon and perhaps some other people may have become convinced of by reading, Nick Bostrom's book Superintelligence, or reading, some of Eliezer Yudkowsky's writing. So this is predicated on an assumption that is just false, which is the existence of hard takeoff. Right. So the fact that the minute you turn on a super intelligent AI system, it's going to take over the world, and it's going to escape your control. And it's going to refine itself to be even more intelligent. And so, and the world will be destroyed. And that's just ridiculous. It's just completely ridiculous. Because there is no process in the real world that is exponential for very long. Those systems will have to recruit all the resources in the world. They will have to be given, limitless power agency. Why would we do this? And what's more, they would have to be built so that they have a desire to take over. Systems are not going to take over just because they are intelligent. Because again, even within the human species, it is not the most intelligent among us that want to dominate others.
So his desire, and many other leaders' desire, to prevent any further development and to regulate intensely right now and stop all progression is BS, basically.
It's obscurantism.
Yeah.
Right? It's like people who wanted to stop the printing press and the diffusion of printed books because, if people could read the Bible for themselves, they wouldn't have to talk to priests anymore, and then would have their own idea about religion. And that's exactly what happened. People read the Bible for themselves, and that created the Protestant movement in Europe, and that created 200 years of religious conflicts. But it also brought to us the Enlightenment. Science, rationalism, philosophy, ideas of democracy, and then the French and American revolutions. And then, you can compare this with the Ottoman Empire, which, for reasons of being able to control their population, basically forbid the use of the printing press. And it started 300 years of decline. They were dominating science in the Middle Ages, the Muslim world, which is why, every star in the sky has an Arabic name.
I love this. I'm going to do a quick fire round with you now. So I say a short statement and you give me your immediate thoughts, and then we'll rock and roll. Does that sound okay?
Sounds good.
So which regions most need to change their modus operandi when it comes to the practice of scientific research and incentive mechanisms?
Which region?
Ned.
Oh, wow. Pretty much every region, I'm afraid, but for different reasons.
Sure.
So let me start with China. So China has a bit of an epidemic of bad science. There are a lot of very smart people in China, a lot of very good researchers, a lot of very good work coming out of China, particularly in AI, particularly in computer vision. But a lot of absolutely terrible work that has to be retracted a few months later. It's been published. And it's partly because of the incentive mechanisms in the academic and system in China. So there's a problem to fix there. I can move to Europe. So in Europe, there are good things. So the education system for like undergraduate education in Europe is great. It's fantastic because it's partly free. So that allows talented people to go to the schools even if they're not rich, right?
Sure.
Which is not the case in the US, for example, at least not to the same extent. That's good for Europe. A lot of European engineers and scientists are great, top, best in the world. But then what are the opportunities for people who want to go into science and research? And there, most European countries actually don't have systems that really encourage this and motivate the most talented people and students to go into science. And so some of them go to North America, like me, 35 years ago. There are opportunities now that are really good in research labs like FAIR in Paris, or Google also has labs in Paris. Actually, my brother works at Google in Paris. So there are other outfits. So that gives opportunities for people who really want to be productive and don't think that they can in the sort of public research and academic system in France and the rest of Europe. The only European countries that can rival the US in terms of the quality of job for an academic or a scientist is Switzerland.
What do you think they do to rival that? What is it about their incentive mechanism structure that gives them that ability?
Two things. They pay people better. Second thing is they give them resources for research. They can get extra resources through grants and stuff like that, but they're good. And then they also attract some of the best students in the world. So you get the ideal combination that you only get in the top 30 universities in North America.
So we've got China, we've got Europe. What about the US? What could they do differently or improve?
Well, so there's a lot that the US does right in terms of research, which is to a large extent a bit of a partial explanation for the success of the technological industry, the tech industry in the US. I think, partly because the US devotes significant amount of resources to fundamental research through NSF and NIH and, various other outfits, probably more than Europe. Universities pays their faculty pretty well, particularly in areas like computer science and AI. Now, this comes with a downside, and the downside is that studying in the US is expensive. It's a trade-off, right? So can you do one without the other? Switzerland figured out how to pay academics pretty well while actually offering free education to their students. So, there is a way to do it. Canada also figured out a pretty good trade-off as well. So a lot of things the US does right, but one thing that the US system or lack thereof does right also is the willingness to take risk and invest on ideas that seem, a little crazy, but basically, the sort of vibrant startup scene in Silicon Valley and other places in the US, in New York and in the Boston area is leading the world. Now, you start seeing a similar thing in Europe now. There's been like an enormous growth, for example, of tech startups in Paris area, in France more generally, and continental Europe a little more widely, and in the UK as well. And so I think that's a good thing. But it's still a little more difficult to have access to investment money in Europe than it is in the US.
That's why I'm here, Yann. I'm happy to provide. I'm going to do a penultimate one for you. When you think about what you'd most like someone listening to take away, what would it be? When they hear this, what do you want them to take away as the number one thing?
AI is going to bring a new renaissance for humanity, a new form of enlightenment, if you want, because AI is going to amplify everybody's intelligence, right? It's like every one of us will have a staff of people who are smarter than us and know most things about, most things and most topics. So it's going to empower every one of us. It's going to make us more creative because we're going to be able to produce text, art, music, videos without necessarily having all the technical skills that are currently required for doing those things. And so exercise our creative juices. So that's the positive side. There are risks, there's no question, but it's not like those risks. Don't believe the people who tell you that those risks are inevitable or that they will inevitably lead to catastrophe. That's just not true. It's like, place yourself in 1920. Like, who would have thought that a mere 50 years later, you could, cross the Atlantic in a few hours in complete safety, at near the speed of sound? Would people seriously want to ban aviation or call for regulation of jet engines before jet engines existed? I mean, that's kind of insane. So I'm not against regulation. There should be regulation of AI products, particularly the ones that involve making critical decisions for people. But regulating or slowing down research is complete nonsense. It's just obscurantism.
Whose incumbent team do you most respect and admire when you look at Amazon, Facebook, Google, in terms of their approach and talent internally, outside of Meta, obviously?
So this is changing a lot. And the reason it's changing is because a lot of people are leaving large companies and large labs.
Yeah.
And the reason they're doing this is that until recently, a lot of AI research was very exploratory. And now there's a path towards commercialization for a lot of things. And so people think that they're better off just, leaving large companies and doing this on their own, doing a startup and things like that. So you see a relatively large motion of applied research engineers, a few scientists, basically leaving those labs to do startups. And that's across the board, right? So you look at the original paper from Google about BERT or transformers, right? The thing that revolutionized NLP. All of them have left. Okay, they're all in startups. Some of the people who produce LLaMA, the open source LLMs from Meta, so the key people have left already, okay, to do startups.
I saw their companies.
There's one what is called Mistral.
That's the one I saw, yeah.
Right, but they raise an insane amount of money in days.
So,
more power to them. But I'm sad that they left Meta, obviously. But
whose existing team are you like? Yeah, they're good.
Yeah. So, but I think like in terms of the sort of basic competence and the people who are going to push the science forward, because what we need now is not to work on applications of LLM. There's a lot of people who are capable of doing this, and they're going to do a good job. What we need to do, people like me who are really working on research, is kind of coming up with new concepts that will allow us to, get machines that basically have common sense, have an experience of the real world, have, basically human level intelligence, right? And, in my opinion, the outfits that are best positioned for this are FAIR on one side, and the new DeepMind now, which is, DeepMind plus Google Brain.
Yeah.
There are a lot of people there who are interested in that question, and I think they are probably the best, together with Meta and FAIR, they're the best position to really kind of have an impact on this, something, all of us have been working on for quite a while.
Yann, if we do this again in 10 years' time, where is Yann in 10 years' time in 2033?
Well, I'm 63, so, 10 years from now, 12 years from now, I'll be Jeff Hinton's age, okay? And I don't know. I think I'm excited like a teenager now because I see the opportunity of like the next step in AI and opportunity perhaps to, get to the goal that I set myself, so that I imagined for myself when I started working on AI many years ago, which of course I was very naive about at the time, of understanding intelligence, first of all. And it's a scientific question. What is intelligence? What is human intelligence? And one good way, as an engineer, a good way to understand intelligence is to build a widget that actually reproduces it, right, to some extent. I'm excited about this right now. I'll find the substrate, the landscape, the location, the position where I can make the best contributions to this. And currently, that just happens to be fair at Meta. I keep a foot in academia because I think it's very complementary and also important. There are projects of different types that you do in academia and industry that are complementary. So I like the combination of the two. As long as my brain keeps working, that I think I can contribute, and that I'm given the means to contribute, I'll keep working. And then there's some point where my brain will turn into white sauce, or I'm totally out of it or something, and I'll stop.
Yann, I want to say personally, thank you so much. I speak for many, I'm sure, when I say we've learned so much from you in terms of your public speaking and discourse and willing to speak. I think few are willing to speak as openly as you have been. So thank you for educating so many of us, and thank you so much for joining me today, Yann.
Well, thank you so much for having me, Harry. This was fun.